speeding up your code with Cython. We're switching gears again. Numba is cool, no question about it. Numba lets you take Python code and make it fast. Before Numba, there were other ways, though, to generate compiled code that you could use from within your Python functions. One of them was Cython, or still is Cython. And while I don't recommend Cython really anymore for going from a Python code and trying to speed it up, it is one of the most Pythonic ways to generate language bindings to existing libraries. But to use that properly, we need to know something about Cython and how it works and what it does. So that's what this is about. Cython is a language that makes writing C extensions for the Python language as easy as Python itself. That's a big statement, and one that I won't sign off on completely. But in principle, just to start out, it may actually be true. Cython can also be used within Jupyter Notebooks if you load the proper extension. The question came up earlier what this actually does. This is not a Python command. So the notebooks actually act on different levels. You can execute Python within the notebooks, within the executable cells. The Python magics, though, act on the notebook as a whole. So when we load an extension like this, we basically make a new magic available, the Cython magic. Let's start with this function. It's a dot function, actually multiplying two arbitrary iterables v and w, where I have where I can define a multiplication, have an indexing operation, and have an addition. So this function can take, for example, a list or NumPy array or anything else that is iterable and has at least one element. So this is a very generic function. If I use the Cython magic on a function like this, then Cython takes this Python code and generates C code from this. And this C code is then compiled into a C extension for Python that I then can load as a dynamic library. Basically, I do an import. The Cython magic actually does this behind the scenes. One very cool feature of Cython is that it can generate reports. Here you see that this code is rather yellow. Kind of looks greenish yellow, but anyway, it's yellow. And maybe you can tell that there are some lines that are a little less yellow than the rest. You also see that there's a plus sign in front. And I can actually click on this plus sign and see the C code that is generated for this particular line. All right, so this is actually translated into a for loop. This for loop isn't that bad. But there's also some checks and Python object length in here that don't allow huge optimizations. Now, if I let code run like this without any further specification, it will be a little faster than the comparable Python function, mostly for two reasons. If I have something like this, it might actually be faster than the Python loop, but mostly because I skipped the overhead of interpreting it. If my Python interpreter goes through here, it has to go through this line by line again and again and again, and that generates some overhead. It basically needs to parse, it needs to then call the appropriate C functions in the CPython interpreter. So I'll gain a few percent, and you'll do the measurements later. What really gives me an advantage is if I can be more specific about what I need. Let's say I really only want to multiply NumPy arrays that are of type integer and one-dimensional. Then I can specify that. I also specified here that my result is actually a long integer. And I also define n here as an integer. N then is the length. I'm still checking the same conditions as before. And I still do the same loop. But now this, yes?
So is this int now really a C int or is it more Python int?
The question was if the int is now a C int or a Python int. And the answer is, since that's a CDEF in front of it, it's a C int. It actually is not visible outside of Python, outside of this function. It's not visible to Python at all. Okay. Thought I actually had the, but I guess I wanted to leave it to you. Skipping checks. If you look at that code, you'll still see some extra if statements. So that code will be faster than what we had before, actually quite a bit. But Python does funny things with arrays. One thing is I have bounce checks. So I'm actually looking for if I go over my boundaries. The other one is wraparound. And if I know that this is not happening, I can turn that off and generate even more C-like code. So here now I turned off bounce checks and wraparound. Now this means that if I'm accessing my array with indices that point outside, this is just as bad as it is in C. It will do horrible things. It will access memory that was not allocated. It might crash your program. There's no protection anymore when I do this. I'm really turning off safety guarantees, and you'll see how much time we gain from that, and you then have to decide for your problem if that is worth it or not. Now, I mentioned that Cython generates C code and then compiles it. The Cython magic can take some compile arguments that are passed to the compiler, and actually also some linking arguments that I'm not using here. So here I'm just I'm passing the optimization level 02, and I'm telling it that I'm using the native architecture. Since Cython is C, why not do OPENMP from within Cython? Now, for OPENMP, the first thing I have to keep in mind is that I actually have additional compile and link arguments that I need to add. When I have those, once I have set those, though, I can use the Cython parallel function. So here from Cython parallel, I import parallel NP range. And now I can use, instead of the range command here, I can use a p range. With no GIL equal to true, that means I'm vouching that I'm not accessing any Python objects within this loop. If I do it anyway, again, horrible things may happen. But in this case, it's actually not trying to be smarter than the programmer. Now, notebooks are cool to try them out and develop a Cython extension because you can do a rapid iteration cycle, especially while you're trying out what each of these optimizations does for you. Notebooks are actually very nice, and the Cython extension allows you to basically skip your usual compile run cycle because it's all done for you in the background. But eventually, you'll probably want to ship your extension, not just in a notebook, but also have it generally available. And then you usually generate a setup script. And you probably have seen SETUP.PY files before, where when you wanted to compile a Python extension. So this is a simple setup file. It would take a file sum.pyx, that is the usual extension for Cython files. Here we give it a name, and it will then generate a module and a dynamically loadable library. You can also add compiler options here. So here I now define an extension sum. The file is sum.pyx. It takes the extra compile and link argument f_openmp. And again, it is a sum of integers here, builds an extension model, Cythonizes it. And how to build it actually is described in the notebook. So far, we have just done simple functions, or a simple function, really. But Cython can also generate classes. Here we have a very simple point class. And when you have a def in front of it, this is a Python function. If you have a cdef in front of it, it's a pure Cython C-level function. If you have cpdef, it's something in between. So, but at this point, we can, when we have an extension built like this, we could generate a point, 0, 1, and we can even print it. And you'll see what the result is in your notebook. There's a second type of class, a lightweight form of class called an extension type. An extension type stores its members and methods in a C struct. It's a little limited in terms of what you can do with it, because it doesn't store everything in a dictionary. So it's much harder, for example, to just add a method later. But it's also more memory efficient and can be faster. Extension types are basically defined like this. So you have a cdef class here, and you represent your class like this. So this double xy here, the double distance to origin, for example, are functions that are then later called from or available as class methods. Notice the special method cinit here. It's called instead of the init function. All right, and you can basically use the function the same way as before, and you'll see that in the notebook. All right. The notebook is called Speeding Up Your Code with Cython. And you can get to work.